Today we are going to discuss about recursion. Recursion is one of the most important concepts in data structures and algorithms, as well as a bit complex concept as well. It will be difficult to understand in the beginning, but if you once understand the concept clearly, you can solve the problems very easily using recursion. First of all, before going to start the concept recursion, let me explain a use case where how we can use the recursion. Suppose I have suppose I want to print the values from 1 to n. I want to print the values from 1 to n by using the concept recursion. I should not use any loops. Here the conditions are I should not use any loops, and I should call the function only once. Let me explain. Suppose I have taken a number int n is equals to 5 here, and I want to print. I'm calling the function print. Okay, I'm passing n here. Let me write the print function. Int print int a. I want to printf percentile d comma a. Okay, here if I try to run this code, I'll get only once. But here the condition is I need to print the values from 1 to n. Okay, 1 to n in descending order. How can I print? Here, I can call the same function within the function. A function calling itself is called recursion. What is meant by recursion? A function calling itself is called recursion. This is a very basic definition of recursion. But how it going to call? How it going to implement? Let us discuss now. Now, suppose I'm calling the same function print a, right? I'm calling a minus 1. If I run this code, initially main function will be called. Okay. I need to print until 1, right? For that, I need to place a if condition. If a equals to 1, then I'll print the value printf percentile d comma a, and I'll return the function return 0. What's going to happen if we write the return? It comes out of the function. It returns to the function call, right? See, let us run the code. We got the output 5, 4, 3, 2, 1. Okay, now shall we see the how it going to execute and how it going to store the function in the stack memory. Let us discuss that. Initially, our main function is called, right? Initially, our first of all, in the main function is called. After calling the main function, we called print function, right? Print, and we have passed 5. We have passed the value 5. In the 5, it prints the value 5, and within the same function, if you observe the code, if a is equals to 1, no, the condition is false, right? Because a value is 5. It going to, the condition is false. Next is going to execute the next line, printf percentile d comma a. It prints the value as 5, and it going to execute the next line. What is this? Print a minus 1. Is it look similar to this line? Print n. Yes, right? Here, this is a function call. Here also, function call. This is also called as a function call. We are calling the function within the function, right? This function is going to call the same function. From the third line onwards, it's going to execute again. A minus 1. What is the value of a minus 1? 5 minus 1 gives me 4. Again, it's going to print int value as a is 4 now. I'll check the condition. Is a equals to 4 equals to 1? No, the condition is false. It prints the value as 4. Now, again, the condition is okay. Print the 5, and we have one more function, that is 4, right? We call the 4 function print 4 from the print 5 function. Print 5 prints the value 4, print 4 prints the value 4, and it calls the function print 3. Okay, print 3. It prints the value 3, and it's going to call the a minus 1. 3 minus 1 gives me 2, right? Then again it calls the print by passing the value 2. If a equals to 1, no, the condition is false. Then again it prints the value. What is the value of my a now? A value is 2. Again, after printing, after executing this, it comes to the next line. Print a minus 1. 2 minus 1 gives me 1, right? Then we have passed the value 1 to the print function. It prints the value. It checks the condition. If a equals to 1. Now, my a value is 1. Is 1 equals to 1? Yes, the condition is true. And it prints the value 1. And we have written 0. Now, where does the control flow comes? Here, to this line. Until this line, we have executed the code. Let me explain. Yeah, it's running. Please wait a minute. It's loading. Okay, we will. Here, initially, the main function is called main. Right? Main function is called. Next, from the main, I called print 5. Print 5. From the print 5, I called the function print 4. From the print 4, P3, P2 and print function 1. Here, as if the until this, here I have written the function. After printing this function, where should it written? It should return to not main. It should return to print 2 because this function called the print 2 called print 1, right? After executing, it returns the function, it returns the control flow to this print 2 and comes out of the stack. Okay, it got removed from the stack now. Now, where is my control flow? Control flow is at print 2. Print 2 function. Here also, there are no any further lines, right? And here also, it gives the control flow to this P3 and comes out of the stack. Same thing repeats. Okay, P4 returns the function to P5 and comes out of the stack memory. P5 prints the value and returns the function to the main and comes out of the stack memory. This is how the internal implementation of stack memory is going to happen in recursion. Hope it is clear to you. After executing P1, the control flow, okay, print 4, the control flow returns to the function that is called. Suppose I called the P of 3 from P of 4, right? After complete execution, it comes out of the stack and returns the control flow to the previous function that I have called. Hope it is clear to you. Next, if you ask me why should I have written this condition, because this condition is called base condition. What if I miss this condition? Shall we see what will be the output now? Okay, let me run the code. See how many values we have got. This is, it prints the value continuously because there is no any end statement, right? This condition is called base condition. Base condition is a condition where recursion stops making new calls. Okay, base condition is a condition where recursion stops making new calls. If I don't write this condition, it prints infinite values and we get an error called stack overflow. We get error stack overflow in memory management, because the loop is never going to end, right? Main 1, 2, 3, 4, 5, 6, and it never comes out of the stack becomes full. Stack becomes full and we get error called stack overflow. Stack overflow. If you know, we have a website also on this name, Stack Overflow. This is called base condition. Base condition is must. If you miss the base condition, we get stack overflow error. Whenever the function, function finishes execution, it removes stack and flow of program is returned to the function it is called. Until the completion of execution of the function, it remains in the stack memory only. After complete execution of the function call, then only it comes out of the stack memory. Hope it is clear to you. Even if you are facing any issues till now, please go back and rewatch the video once again. It will be clear for you. Okay. As many times as we call the function, it will take the memory separately. For the main separate memory is allocated. For print 5, separate memory is allocated. Same happens with the print 4. Separate memory is allocated for each function call. Okay. You may ask me why we need this recursion. You can solve using for loops and all, right? If you ask me why do we need this recursion, we have very few advantages of using recursion. Let us discuss what are they. Okay, in the first point, recursion, as we know, recursion is called function calling itself. The first very important point is it helps us in solving bigger complex problems in a simpler way. Suppose here, if you observe, we no need to we no need to call the function again and again. It helps us in solving complex problems like towers of Hanoi, and there are few complex problems which can be solved easily with the help of with the help of the concept recursion. Helps us in solving complex problems. Helps us in solving complex problems. Next point is, here we haven't used any for loop, right? But iterations occurred by itself by calling the function. We can convert the recursive solutions into iterations and vice versa, right? Now here the space complexity and time complexity decreases. If you observe, I haven't used any for loop or anything else. It's just calling the function. So time complexity reduces by using the concept recursion. Space complexity is also in here space complexity is not constant, because if you observe in arrays, if you observe in arrays, space is fixed, right? It occupies certain amount of time. But in when it comes to recursion, we don't know how many times the function is going to call itself, right? It may call 5 times, it may call 10 times, or based on until until it reaches the base condition, it keep on calling the function, right? It keep on calling the recursive function. So we cannot predict the space complexity. It varies. It varies based on the requirement. And the main important point why we use recursion is it helps us in breaking down the problems into smaller problems. Suppose instead of writing some 100 lines of code, we can simply write the same logic in 10 to 30 lines. Okay, in 10 to 30 lines we can write the same logic and the same function. It gives the same output. It helps us in breaking down the bigger problems. If we have some complex problems, it helps us in optimizing the code. These are the few important advantages of recursion. Now, I would like to explain the visual representation of recursion. Okay. First of all, for this function, if you observe, for this function initially, which function is called? As we know, the program execution always starts from main, right? Initially, main function will be called, right? Initially, main function will be called. From the main function, we have called print 5. We have called print 5. From the print 5, again we called print 4. From print 4, we have called print 3. Right? In the print 3, again we called print 2. And finally we call print 1. Here, as we have base condition at this function call, it returns the after completing the execution of this call. Okay, it will print the value 1 and it returns the control flow to the function that is called previously, which has called P of 2 called P of 1, right? It returns the control flow to P of 2. The same thing happens here also. After complete execution of P of 2, it returns the control flow to the P of 3. P of 3 returns to P of 4. P of 4 returns to P of 5. P of 5 returns to main function. After completing the main, that's all. Total code executed successfully. Code successful. Right? This representation is called recursion tree. This representation is called recursion tree. This recursion tree helps us to understand the code, understand the internal implementation of recursive calls, how it going to implement and how it going to call the function in the further function calls. If you miss this base condition, entire program clash and we get a error as stack overflow error. It may print the value, but we get infinite values. For if you are writing any code using recursion, you need to make clear. You need to make clear that you should write proper base condition. Base condition is most important thing while writing while writing the program using recursion. Now we are going to see a simple program using recursion. You might have heard of Fibonacci series, right? In Fibonacci series, okay. What is meant by Fibonacci series? 0, 1, 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, and so on. It increases. Right? This is the first one. The sum of these two in Fibonacci series, nth value. Suppose this is nth element is the sum of previous two elements, the preceding element and that and this element and this element. If I get 1 plus if I sum 1 plus 1 gives me next value. To get the next element I need to sum these two. 1 plus 2 gives me 3. Right? For the next element 3 plus 2 gives me 5. The same thing repeats as usual. Now can I say f of n? Okay. Fibonacci series of nth value. Let's say third is equals to sum of f of n minus 1. F of n minus 1 plus f of n minus 2. Can I write in this way? F of 3 is equals to f of 2 plus f of 1. Yes, we can write this way, right? This formula is called recurrence relation. This formula is called recurrence relation. Okay. How I got this means a basic understanding, guys. Suppose here we have, if I want to find nth element, then I need to sum previous two elements, right? Just preceding the preceding element and for that preceding element, right? I need to sum previous two preceding elements to get the nth element, right? Let's take suppose I want to print f of 4. Okay, f of 4, fourth element. F of 4 is equals to what? F of 3 plus f of 2. F of 3 is equals to f of 2 plus f of 1, right? F of 2 is equals to f of 1 and f of 0. And same, f of 2 is equals to f of 1 plus f of 0. Right? Okay, let me explain once more. Suppose I need to print 4 Fibonacci series. F of 4 is equals to f of 3 and f of 2. How I have written? From this formula. Here, f of n is equals to f of n minus 1 plus f of n minus 2. From this function, I have written f of 4 is equals to f of 3 and f of 2. If I want to calculate f of 3, can I write f of 2 and f of 1? F of 3 is sum of f of 2 and f of 1. F of 2 is again f of 1 and f of 0. Right. Here f of 2 is again f of 1 and f of 0. Right. Why I have stopped at f of 1 and f of 0? Because this is the base condition, guys. If you want to identify the base condition, please try to draw the recursive tree. And then you can able to find out the base condition. That means where I have to stop calling the function. Okay. If I get f of 1 and f of 0, I should stop calling, right? These calls, these final calls, okay, these final calls, which are called as tail recursive calls. Tail recursive calls means which going to stop calling function. Okay, last function calls of a recursive tree are called what? What do we call? Tail recursive functions. Okay. Hope it is clear to you. If I want to print f of 4, f of 3, f of 2, f of 3 is the sum of f of 2 and f of 1. Again, f of 2 is sum of f of 1 and f of 0. Okay. How it going to implement internally, we will discuss. Initially, this function, okay, let me take the pen. This function is called initially main function is called, right? Main function is called. From the main function, I have called, suppose I want to print 4 Fibonacci series. F of 4. It will start from left. It will start from calling left side of the tree. F of 4 initially calls f of 3. F of 3. Right? F of 4 initially calls f of 3. And this f of 3 calls f of 2. guys. F of 2 will be called. This f of 2 calls f of 1. Okay. As this is the last call, after executing, it will return the function to f of 2, right? Now, f of 2, it has finished the left part. Then it comes to right part. F of 2 calls what? F of 0. Okay, f of 0. After executing this part as well, f of 2 returns the control flow to now f of 3. Okay. F of 3. F of 2 is sum of f of 1 and f of 0, right? After summing up, we get f of 2. Then, after executing f of 2, it returns to f of 3. F of 3 calls the function f of 1. Okay. F of 1. And after executing this as well, it's going to return to f of 3. Okay, f of 3 is sum of these two functions, right? After executing f of 3, it returns to f of 4. Now, we are done with left part, right? Now, it enters to right part. F of 4 calls f of 2. Okay, f of 2 initially calls left part, that is f of 1. And next, f of 1 calls f of 0, which is going to come first from the stack. After complete execution, f of 0 comes out of the stack. Okay, f of 0 comes out of the stack. Next, after complete execution of f of 1, it comes out of the stack. After printing the sum, this function call is going to end, right? F of 2 is also get cancelled. Next, f of 1, this function call is going to get cancelled. Okay, comes out of the stack. Next, f of 0. Which one? Yeah, this one. F of 0 and f of 1. These two, and next f of 2 is comes out of the function call. It comes out of the stack. Same thing. Next, f of 3, after complete execution, f of 3 comes out of the function call. After completing, then it returns f of 3 and f of 4. F of 4 is sum of f of 3 and f of 2, right? It prints the value and the f4 returns the function call, returns the control flow to the main. This is how it functions. Okay. This is the recursive tree to print the Fibonacci series. Okay. Shall we see the code for this? Okay. Initially, I have taken n as 5, right? Okay, I'll change the condition. If n less than